Dear students, today we will be doing questions based on distance formula, and we have studied how we have derived distance formula using Pythagoras theorem. So we will be taking some questions based on them. We have first example is find the distance between the points A, which has the coordinates 1, 2, and the second point is B, which has the coordinates -3, -2. So what do we have? We can take this point x2 minus x1 whole square plus y2 minus y1 whole square, because whole square is always positive, so it doesn't matter whether you write x1 minus x2, but mathematically we should write x2 minus x1 whole square plus y2 minus y1 whole square. And then you can see, then you have to take particular care of these signs where you are putting the negative signs here, and we can see it is under the root 4 square plus 4 square, and always you are not getting a perfect square under the square root sign, so you will have to find out the value of the square root up to 2 decimal places. So this is the convention. First find the square root up to 3 decimal places and then round it off to 2 decimal places. Now moving on, we have used the distance formula to find the distance between the points coordinates -3, 4 and 5, 2. Now first we have written over here, this is x1 is -3, y1 is 4, x2 is 5 and y2 is 2. So using the distance formula, we have x2 minus x1 whole square plus y2 minus y1 whole square, and this minus minus becomes plus. Simple things you have to take care of again and again, and this -2 into -2, it becomes +4. So here we have root 68. Because it is not a perfect square, split it as a factors, 4 into 17, and it gives us distance equals to 2 root 17. Now moving on, you have to show that a triangle has the vertices given, and you have to show that triangle isosceles. From the knowledge of geometry, we know that a triangle will be isosceles if any two sides are equal. So you will have to find out all the three sides, AB, BC and AC, and see whether they are equal. So when we find AB and BC using distance formula, using the endpoints, one place taking one as x1 y1 x2 y2, and similarly in BC also taking one as x1 y1 and x2 y2, and using the distance formula, you can see that AB equals to BC root 53, and therefore the triangle ABC is isosceles. Similarly, if it is asked to prove that this is equilateral triangle, then you will show that all the three sides are equal. Now we have a point on the y-axis. You have to find a point on the y-axis, each of which it has a distance of 13 units from the point -5, 7. So a point on the y-axis, as I have told you in the video also, it is of the form 0, a. So we can take it 0, y over here, and because it is equidistant, because it is at a distance of 13 units from this point, so from this point, let us take this point to be A. PA equals to 13 units. So using the formula, distance formula, PA, by using x2 minus x1 whole square plus y2 minus y1 whole square, and then whole squaring, we are getting the expression of this form. This is a very important part. How do we solve it? By using the identity a minus b whole square, and then collecting the like terms, and then finally factorizing it. So what are the two factors that we are getting? Y minus 19 and y plus 5. So the solutions will be y equals to 19 or y equals to -5. So we are getting 2 points over here, 0, 19 and 0, -5. So in this way you are going to solve the questions of the exercise also.